We'll see today arithmetic instructions in 8051 part 2 from chapter 2 instruction set of 8051 and addressing modes. Myself Dr. Kurne Faiz Ahmed, Head Department of Electronic Science, Abida Inamdar Senior College, Pune. The 8051 can perform arithmetic operations such as addition, subtraction, multiplication and division. Few of them we have seen in the previous lecture. Now remember that do not get confused between add a comma 30, add a comma hash 30, add a comma at the rate 30 and add a comma 30h, which is here. Meaning of this, the data 30h is added with the content of A. Here it is pointing an address. So go at address 30h, whatever inside that 30 add with the content of A. And here writing at the rate 30h is same as writing only 30h. So here same meaning, go at address 30h, that data will be copied in, that will be added with content of A and the answer will be stored in A itself. So at the rate is data 30, here hash data is 30, this is pointing an address 30h, this pointing an address 30h. Now let's summarize the previous one. If we write add a comma rn, that means content of A plus content of A, store in answer in A. Meaning of this, take data from address, that data plus A. Meaning of this, go at address pointed by Rn, then that data pointed by Rn, that data plus content of A, store in itself. Here the data is given in instruction itself. So data plus content of A, answer in A. This will have with carry. ADDC means content of A plus content of Rn plus content of carry flag. So add these three and then store answer in A. Here content of A plus content of data pointed by an address plus content of carry flag, store result in accumulator. In this case ADDC A comma Rn, so content of A plus content of data pointed by Rn plus content of carry flag and store answer in A. This will add content of A plus data plus content of carry flag and store answer in A. The carry flag will be having either 0 or 1. So CF will have only single bit, either 0 or 1. So that 0 or 1 is added as per the instruction. Now see the instruction CLRA. This will clear the content of A. Whatever in A it will be wiped out and in A it will be 00H. In this case it will increment the content of A by 1. For example, if in A the value is 09H and we give instruction INC A to increment this A by 1. So in A it will be 0AH, not 10, because we are doing increment in hex, not in decimal. Same here, this will increment the content of Rn by 1. So here Rn can be either R0 or R1 or R2 or R7. Same, next is decrement A. So this will decrement the content of A by 1 and the new value is stored in A itself. So let A equal to 7CH. Then this will change the content of A. It will do A minus 1 answer in A. So it will be 7BH. Similarly, we have decrement Rn. So here we can have decrement R0 or R1 up to Rn, decrement the value by 1 and store in the same result, same instruction itself. This will be decrement the content of location pointed by Rn. So here we can have decrement R0 at the rate or decrement at the rate R1. So we'll go at address pointed by R1, decrement by 1 and save that into same here. This is what meaning of this decrement instruction. Swap A, the name itself says what to do. It will exchange the content of A, lower 4 bits 0 to 3 with the higher bits. So if we have a bench with two students, student A and B, they will exchange their sets. This works only on accumulator. So we cannot have a swap B or swap Rn. Only swap A is here. So let A equal to 36. So if we give instruction swap A, then in A it will be opposite 63H. So we'll exchange only the upper nibble with lower nibble. This is what swap A instruction. So here you can see the example. So before we have data in A, D0 to D3 one nibble, this second nibble. After that it will exchange. That's it. So simple. Now next is DAA. Its full form is decimal adjust for addition. This instruction will give answer in decimal. You see the example here. In A we have 17. If we give instruction add A comma hash 28, it will add the content of A with the data 28H. So we're getting answer here 3FH in hex. If we want answer in decimal, that is 45. Then for this we have to give instruction DAA. So DAA is used to correct the problem associated with it. So let A equal to 0. In A here we have A00. Here A is given, add A comma hash 31. So it will be 00 plus 31. Answer equal to 31 in A itself. Now here given instruction add A comma 09. So content of A is what? It is 31 now. So 31 plus 09H. So answer will be here 3AH. But when we write instruction DAA, it will make it 40. Same case here. Add A comma 15. This becomes 55. When writing this instruction, it becomes AAH. But when you give DAA, it becomes 00. It becomes 10. So this way you can have the use of DAA instruction. Thank you. If any queries, please contact me on the mail given below.